Okay, so today's lecture summary, we're going to summary on cognitive psychology. So the main areas we're going to summarize are going to be mental representation and processing, the emergence of cognitive psychology, information processing approach, characteristics of cognitive psychology, processing cognitive psychology, classifications of processing, and research methods for cognitive psychology. So once again, have a moment to think about what you know, what do we know about cognitive psychology. So what do we know about cognitive psychology? Take a moment to think about that. Okay. And can cognitive psychology and biological psychology work together? Can cognitive psychology and biological psychology work together? So biological psychology needs some type of conceptual model of the way in which different components of the skill are integrated. There's no single area of the brain responsible for skills such as reading. Cognitive psychology needs evidence for the models that are produced. These models need to be consistent with what we know about brain functions such as learning and memory. So your thoughts, can cognitive psychology and biological psychology work together? So what is cognitive psychology? So cognitive psychology can be considered, psychologists as investigators, testing predictions about the mind. Cognitive psychology investigates how we store and process information. Cognitive psychology creates models for how processing takes place for human abilities such as memory, perception, language, vision. We are all information processors. Representation is about how we store information. Processing is about interpreting and transforming stored information. So we touched on computer analogies before. But take a moment to think about, is the brain just a living machine? Could we create an artificial mind? What are your thoughts on that? Have a moment to think about that. So do you think we could create an artificial mind? Okay, have a moment to think about that. So Ulrich Neisser could be considered the father of cognitive psychology, an advance for ecological approaches to cognitive research. With the publication of Cognitive Psychology in 1967, Neisser brought together research concerning perception, pattern recognition, attention, problem solving, and remembering. So the emergence of or re-emergence of cognitive psychology has been dated to somewhat 1950 to 1970. The name came from the 1967 book published by Ulrich Neisser entitled Cognitive Psychology. Although several psychologists were already developing similar ideas, such as George Miller published a book in 1960 described a systems approach, rejecting the need for behaviorism and neuroscience. Okay. So what can cognitive psychology offer? What are your thoughts? What can cognitive psychology help us to understand? Okay, what are some of the things that you think that cognitive psychology can help us understand? So perhaps it can help us understand memory, attention, problem solving, eyewitness testimony, vision, perception, mental health. So information processing, a practical approach. So in Badley 1967 suggested that you can get a feel for working memory by doing a simple task. And the task is, have a moment to think about how many windows does your home have? Okay, and make sure you count all sides. How many windows does your home have? A moment to think about that. How many windows does your home have? Okay, some people might find it easy to close their eyes and imagine if it's safe to do so being inside. Don't close your eyes and imagine if it's not safe to do so. They might find it easier to do that. And if you've got an answer, how many windows, Okay, how did you work that out? How do you think that you worked out how many windows there? So humans can be considered as information processors. What visual representations and processes did it involve? Did you use visual memory and numerical memory at the same time? Have a moment to sort of think about how you work that out and how it works. Okay, so the image will be set and manipulated in your visual spatial sketchpad. The tally of windows will be held in a phonological loop as you count them, subvocally even. And the whole operation will be supervised by central executives, which will allocate the tasks and recognize when the final total has been reached. Okay, so just take a moment to think about that. And we can use other examples. So you can imagine, okay, if you think for a moment, say, like driving, for example, is an automated process. So how are we able to react to the demands of our sensory visual information and navigate our way home while mentally walking around the supermarket, shopping aisles, thinking what we need to buy? Okay, so you're in a situation where you walk around the supermarket. How do we react to the demands of sensory visual information, navigate our way home while mentally walking around the aisle, think we need to buy? Or visualizing the kitchen, for example, cupboard. You might be thinking what we need to buy from the shop. So we do this whilst being able to respond to visual information on the road and maneuver the car, react to traffic lights, signals, for example. So I want you to have a moment to think about other examples of that. What are some other examples you can think about? Okay, what are some examples that you can think about? Is there anything that you can sort of have some time, have couple of minutes to sort of think about similar examples to what we sort of just touched base on? Okay. Okay, so what do we mean by mental and representing processing? What do you think we mean by that? Okay, what do we mean by mental representation and processing? What do you think that means? Okay, any thoughts what that might mean? Mental processing? Anything that might mean? Okay. So I want you to take 5 minutes to think about that, if you can. Okay, a moment to, so I'll pause for a moment and I want you to think about that. So what we mean by mental processing and mental representation and processing. So representation is about how we store information. For example, when we learn a new word, we need to store information of the word. We meet a new face, we need to store information about the person. That's representation. Processing is about interpreting and transforming stored information. For example, when you are reading, you're retrieving. Think about last time you read, or when you read, next time you read a sentence, you're retrieving the information, the knowledge that you have stored previously when you've learned the words. So you may not have to read a sentence. You may have not read a sentence before. However, you can use the knowledge about the current sentence, which you already store in some way, to try and interpret a sentence. So schema, for example, is a mental representation that enables us to organize our knowledge into categories. Our schemas help us simplify interactions with the world. They can be mental shortcuts that can both help us or hinder us. You can make a case in point for that. It's another story for another day. We use schemas to learn and think more quickly. Retrieval is about recalling information stored and being able to use it. So being able to use the information is retrieval. So what's the difference between behaviorists and cognitive psychologists, do you think? Have a moment to think about that and maybe write that down. So according to NISA 67, the term cognition refers to all processes by which sensory input is transformed, reduced, elaborated, stored, recovered, and used. The sensory input from the environment, such as light and sound, are processed by different internal processes, including thinking and decision before response is made. Stimulus, organism, response. Information processing receive various inputs and carry out processes produce outputs. So you've got like the world, for example, what's going on outside, in the outside world. You have internally our perception, our memory, and a plan, and then an action. So world outside, perception internally, mentally. We have perception, memory, and plan, and then we have an action. Okay. Whereas behaviorist, stimulus, organism, response. And you probably, when you think about behaviorism, you probably think about certain famous study in the behaviorism field, like Pavlov, stimulus, response, the dog, the salivation, where they paired stimulus with the food, with the bell ringing, and then when they rang the bell, the dog would salivate. Watson Rayner as well, where they paired the Little Albert experiment in the 20s, where they paired the loud noise. A 9-month baby would hold a white rabbit, and then what they did do is they made a really big loud sound behind the baby, which would startle the babies. Then obviously the baby would sort of become afraid of the white rabbit. Obviously it's not an ethical experiment to do now, but that sort of gives you an idea the behaviorism. Whereas like when you think of cognitive psychologists, it's the world, that perception, memory, plan, and action. So language, the cognitive versus behaviorist debate. So for example, we sort of touched before based on Skinner. So the real role of reinforcement in language development, nurture. Noam Chomsky, language acquisition, LAD, maturation, cognitive process languages all have similarities. Do you believe we can learn languages by reinforcement alone? Do you believe that parents reinforce children's attempts to speak? What are your thoughts around that? So think about the role of reinforcement, Skinner, language development, like nurture. And take a think of what other areas of psychology, cognitive psychology and therapy, how does psychoanalytic and cognitive approaches to treatment differ? Okay, what are your thoughts? So we've sort of discussed psychoanalysis previously, but what are your sort of thoughts on that? Can psychoanalytic therapy help people get better? Can cognitive therapy help someone deal with traumatic experience? What's your thoughts? And perhaps if you'd like to sort of go away and do some reading and research in that area, that would be great. Okay, so information approach according to Nisa. Nisa's book, 1967, entitled Cognitive Psychology. According to Nisa 67, the term cognition refers to all processes by which sensory input is transformed, reduced, elaborated, stored, recovered, and used. The sensory input from the environment, such as light and sound, are processed by different internal processes, including thinking and decision-making before response is made. Information processing receives various inputs and carry out processing, producing output. Okay. So if you take a moment to think about that, and there's a study, the black box explanation by Quinlan and Dyson, 2008. So Quinlan and Dyson, 2008, note that cognitive psychologists are trying to figure out the internal workings of this black box merely from observing its behavior. That's page 34, 208. Stimulus, attention, perception, thought process, decision, response to action. So characteristics of an experiment, trying to figure out what is happening inside the black box use of experiments. So research questions, what are the variables? Independent variable is what are we varying dependent variables? What are we measuring? So hypothesis, testable prediction of relationship between independent and dependent variable, experiment and observation. So we'll try an experiment. Okay, so a memory experiment. Okay, primary and recency effect. We're going to replicate the famous experiment by Glanzer and Koenigs, 1966, who did an investigation into the way position of words can influence recall, serial position effect. So you'll hear a list of 20 words that you must later recall, and recall as many words as you can. Remember. Afterwards, score which were correct, gather data, and work out words remembered. Okay. So the words are red, desk, purple, carrot, crisps, aeroplane, silver, swing, mouse, dog, traffic, handbag, dragon, booklet. So recall as many words as you can remember, and you can slow down the video, or you can, in the presentation I send you, you can have a look and see how many words gather data, how many words you remembered. And what we can do after that is what control measures and the extraneous variables in this experiment. What was the hypothesis for the study? Identify the independent variable and the dependent variable. Model of memory, primacy, and recency effect explained. So sensory memory, attention, rehearsal, short-term memory, rehearsal, long-term memory. Primary recency effect demonstrates short and long-term memory. This can be explained using one of the earliest models of memory as proposed by Atkinson and Schifrin, 1968. So input stimuli, sensory memory, attention, short-term memory, forgetting. Then you've got rehearsal, encoding, long-term memory, it loops back, rehearsal, retrieval, back to short-term memory. And we'll sort of discuss this in more detail as well. Okay. So how do we design experiments? Well, we make a prediction of what should occur based on theory. We create a hypothesis that we can test. For example, the more we process an item, the easier we become to remember. We decide how we will manipulate this variable. We're interested in the independent variable. We decide how to measure what effect it's having. For example, recording reaction times or error rates under difficult task conditions with a set of words. We collect data for each of our experimental conditions. For example, error rates for recalling words, learn only through hearing them or by counting the numbers of the letters in the word, or through having to decide whether they rhyme with another word. What are the mean error rates across participants of each condition? Are the means significantly different based on statistical testing, such as the t-test? Okay. So there's an experiment that is for you to have a go when you can, in your own time and your own pace, and I'll post that for you as well in the slide. The experiment's been created for you to try. It's based on a lexical decision task by Meyer and Chavanel, 1971. It was produced by, it's produced by Sci Toolkit, a free experiment building site by Stowe 210-217. So we'll send the link through and try running yourself on this memory experiment. Write down the mean values you get for each condition when the experiment is complete, and we'll compare the values to see whether they're significantly different. After you've finished, you can do a search for the information about the lexical task. What was the hypothesis? Did it support the data? Okay, so you'll have a go. You can have a go. It'll be in the slide for you. And how do you look for significant result? We collect together the mean values that each participant got for each of the conditions. What's the overall mean for each condition? Usually we would carry out statistical tests that tell us whether it is likely that the data from the three conditions came from the same distribution scores, whether they are too different to have been measuring the same thing. Were your means very different for the conditions that were tested? What about the group as a whole? Which conditions were easier? The experiment tested how long it took you to correct and identify the words presented that were actually words or not. Is it meant to be easier to identify words when they're presented in close proximity in another related word? This is said to reflect the related words are able to trigger activation of the other words, speeding up the response times. So serial versus parallel processing. Processing can be classified as either parallel or serial. In parallel processing, two or more tasks can be carried out at the same time. In serial processing, one task has to be carried out before the second task, and order to the task. Models of why processing is serial or parallel, conflict in resources, parallel selection during visual tracking, and fast counting, known as subsidization, according to Alston and Humphreys 204. how many items can you count at once? Why is it limited? Why does it vary, and how salient the items are? So it's difficult to count 5 plus, easy to count. So we can do an activity, and one activity you can do going forward is to research the experiment to find out more about it. See if you can find a practical to do. So what we'll do, I'll post a practical for you in discussion forum. Processes that can be classified either parallel or serial. In parallel processing, 2 or more tasks are carried out at the same time. In serial processing, 1 task has to be carried out before the second task, and there is an order of tasks. Models of Y, processing is serial, parallel, conflict with resources, parallel selection during visual tracking, and fast counting, known as subsidization, according to Alliston and Humphreys 204. How many items can you count at once? Why is it limited? Why does it vary with how salient the items are? So it's difficult to count 5 plus, easy to count under 5. Trick and Fossil 94 suggested that we only have 4 spatial tags for referencing objects. Research suggests that it may reflect the inability to represent more than 4 salient locations. Large numbers of items must be selected serially. So what we can do is we can sort of read the abstract from the article and let's sort of look into what it's sort of telling us. So we'll sort of do that, and I'll post that for you, and I'll go through it next time. Okay, so top-down and bottom-up processing theory. So top-down, goal-driven, building a representation of using task information, matching a target template. Bottom-up, stimulus-driven, initial automatic, combining of simple features, representation produced from simple processing. So the definition from the American Psychological Association, APA, top-down processing, perceptual processes in which information from an individual past experience, knowledge, expectation, motivation, and background influence the way perceived object is interpreted and classified. Bottom-up processing, perceptual analysis based on sensory data available in the environment. Results of analysis are passed upward towards a more abstract representation. So what you can do on the slide as well, that I'll send you, is visual search based on stimulus-driven feature maps. So you search through the map the relevant feature, looking for a location where the feature is present. And this relies on there being a feature map for the feature the search is based on. Or does efficient search rely on goal-driven guided search in which you're looking for specific features? You direct your attention to relevant features that match the target you're looking for. So Treisman and Gallade, 82, featured integration theory, stimulus-driven feature maps. Duncan and Humphreys, 92, matching stimuli to target templates. Okay, so what I'd like you to do is if you're able to look into different approaches, experimental psychology, connectionism, neuroimagery, and cognitive psychology, neuropsychology. So I have some time to sort of research the different approaches of research methods. So I'd like you to sort of go away and have a think about what are the research methods in cognitive psychology, and research the different approaches: experimental psychology, connectionism, neuroimaging, and cognitive neuropsychology. And computational modeling. There are 2 types of computational modeling approaches. The first is rule-based system or symbolic system, which is like the traditional computer system, where computers run programs, which are a list of commands. The second is the more biological-based computer system, known as artificial neural network or connectionist network. The rationale for modeling work is that if a computer can predict human behavior, the model can be correct in predicting how humans actually carry out the same task. So just in summary, take a moment to think about what are the key features of cognitive psychology. What is the computer analogy within cognitive psychology? What do processing representation mean within cognitive psychology? What would an example be of parallel processing? What would an example be of serial processing? And I'd like you to have a moment to think about, take some time to perhaps write down how we can investigate the effect of level processing level of processing information, the ability to recall it. The levels of processing theory, Craig can log Heart 72. So in preparation for our next session.